Okay, so let's have a look at another question from the 2022 HSC Advanced Maths paper. This is question 16. The parabola y equals x squared meets the line y equals 2x plus 3 at the points minus 1, 1 and 3, 9. Find the area enclosed by the parabola and the line. Okay, so this is going to be the difference between two integrals. What we really have is a line that casts a shadow down to the x-axis. This will be the integral of 2x plus 3 dx from minus 1 to 3. And then we have the parabola, which casts a shadow down, which is these bits, and this will be the integral from minus 1 to 3 of x squared dx. Now we need the bit that is formed between these two, so we're going to be subtracting the second one from the first one. This will give us the area that we're after, the enclosed area. So this implies the area is equal to the difference of these integrals. Now these integrals have the same bounds, so we can put them into one integral. So this is minus 1 to 3 of 2x plus 3 minus x squared dx. So 2x, this becomes x squared. 3, this becomes 3x. Minus x squared becomes minus x cubed on 3. We have to evaluate this from minus 1 up to 3. So this gives us 3 squared plus 3 times 3, which is 9, minus 3 cubed on 3, which is just minus 3 squared, minus the lower bound evaluation. Minus 1 squared is 1, plus 3 times minus 1, that's minus 3, minus minus 1 cubed on 3. Now, minus 1 cubed is minus 1. This is the negative of that, so this is plus 1/3. We have a 3 squared here, a minus 3 squared here, so this becomes 9, minus 1 plus 3 minus 1/3. This minus here has to be applied to all these terms, so it swaps their signs. So now we have 9 minus 1, that's 8, plus 3, that's 11. We have 11 minus 1/3, so this is going to be 10 and 2/3 as a mixed number. We could also write this as 32 on 3. So 32 on 3. These are both equivalent answers, and so therefore the area is equal to 32 on 3 units squared. We're not actually told what the units are, whether it's centimeters or meters or whatever, but we are told that it's an area. So while it is true that this is an integral evaluation, you do have to say it's in units squared because you're being asked find the area enclosed. Now this is a 3-mark question, and it's a pretty straightforward 3-mark calculus question. For the first mark, you have to provide some kind of integral expression for the area or equivalent. So something like setting up the fact that the area will be a difference of integrals as a single integral, 2 integrals, something like that. For the second mark, you'll need to correctly start to evaluate the integral. So you'll need to do the first few steps where you antiderive the functions, and then to get the third mark, you'll have to correctly evaluate the integral and present the answer. So 10 and 2/3, 32 and 3, something like that. That will get you the 3 marks.